All right, class. Today is Thursday, the 10th. We are going to go over the warm up. You should have already completed the warm up. Please make sure that you show your work. Please make sure that you show your work. Okay? Don't just write just answers only. Please just show your work. Um, Afterwards, we're going to work on graphing today. You have to get some graphing in, exponential functions. Okay. Your quiz tomorrow is only going to be on the finding your initial value, your common ratio or growth decay factor or change factor, all mean B, or and finding the percent increase or decrease. You're going to have to know how to do those things. Okay. Also, a little bit of comparing linear tables to exponential tables. With a linear function, you add or subtract to get to the next number in the table. With an exponential function, you're going to multiply. Even if it looks like you're dividing by 2, you're really multiplying by a half, okay? The half will be your common ratio. When a number is less than 1, when the common ratio is less than 1, you know it's going to be exponential decay. When the common ratio is greater than 1, you know that it's going to be exponential growth. Okay? So please go back over that so you're able to identify, just like we did in our activity yesterday. Knowing and understanding how to do those things is going to help you on your quiz tomorrow. Are there any questions about anything that I said? Today, we're focusing, however, on graphing. Do I need to add in there finding B or finding whatever? Does anybody need to see that again? All right, so we're going to be focusing on graphing and we're going to be doing some things out of the booklet. Okay. Um, our homework tonight, we got the Thursday homework. Let me make sure. And yes, I am going to make a help video on that. So please make sure that you watch the help video. Questions, comments, or concerns? Okay. All right, tomorrow we're going to submit our work and we have our quiz. Once you finish with your quiz, you can work on already. Just the stuff that I just said. Initial value, finding the percent, finding the. What's wrong with you? Oh, he getting on you because I said that, and he heard what I said, and you didn't hear it. I was listening. Oh, goodness, Sammy. He was listening that time. That is good. But that's what it's on, okay? So the stuff we did on the. Just, yes, hold that up. So that stuff right there. Cameron, do you see it? Those things. And comparing linear to exponential. Homework is always on Friday. We don't have any homework, so you can spend the time making up work if you have makeup work. And I ready. Okay, let's write in our planner. I write your stuff in blue. We do have homework. We have a homework help video that I'm going to post on Canvas. You're in blue. This is the 10th. Math 1 homework. I am going to make a homework help video. I'm not going to answer all of the problems, but I am going to do an example of each kind. Okay? If you have additional questions, you can text me and say, Ms. Reyes, can you help me work out a problem? And I'll be more than happy to work out a problem and send it to you. But please watch the help video first. I ready? The 18th. Ooh, the 18th is next week, y'all. Ooh, she rolled up on us quick. That's due February the 18th. I didn't realize this. Ooh, Jesus. It's 4 weeks. That went by quick. It's the 4th week already. Next week. Sheesh. And don't forget about your quiz tomorrow. assignments to do. You can go ahead and submit work tonight if you want to go ahead and get that out the way, the warm up, all that stuff. Anybody still copying the homework? Okay. I'll pause for the calls. Let's look at the warm up. All right, so here we're going to simplify this. So we need to simplify the numerator first, and then we're going to divide. So let's simplify the numerator first. Here, do the operations within the parentheses. There's no operation to do here, but here we have power of a power. We have 4 raised to the second power, so that's going to be x to what power? The 8th. So we have 2 x to the 3rd times x to the 8th now. So the coefficient or the number that's automatically in front of this x is 1. Let me just bring this over. So let's multiply the numbers together, and that gives us 2. And we multiply x to the 3rd and x to the 8th, that gives us x to the what power? No. It's 11. Remember, we have 8 to the 3rd times 8 to the 8th. You're adding the exponents, so that's going to be 3 plus 8, which is 11. Okay? This is on the bottom. All right, so let's do the numbers. What's 2 divided by 8? Let's reduce that. That gives us what? 1/4. And then we have 11. X to the 11th divided by x to the 11th. That's going to be x 11 minus 11. What's 11 minus 11? 0. What's x to the 0 power? 1. Okay, so we have 1 times 1/4 is just 1/4. Any questions? Yes.
How come you didn't do the exponent for the first one?
Which exponent up here?
Yeah.
I did. 4 times 2 is 8.
I'm talking about the other one.
Which one? This?
Yeah.
There's no exponent here to do. All of this is in the parentheses together. There's no exponent on the outside.
Oh.
Does that, you see what I'm saying? You got it? Yeah. Anybody else? Good question, okay? Any other questions? Dalton, you have a question, babe? No? Okay, good. All right. Anybody still copying? All right. Let's look at the other. It says Romy opened a gift shop in 1995 and it closed in 2000. In 1995, her inventory of stuffed animals was 350. Okay. In 2000, her inventory was 0. Let X represent the number of years since 1995. So we have 2 ordered pairs. The first ordered pair, 0 year, how much was in the inventory? 350. Okay. And in 2000, how many years is that after the 0 year? So 5 years later, the inventory was what? 0. Okay. So now we're going to find the rate of change. We got x1, y1, x2, y2. Okay. And then what's wrong? Donnie, what is it?
I'm good.
Okay. Please stop doing that, sir. Okay. Y2 minus y1 over x2 minus x1. So on the top, we're going to subtract what 2 numbers?
0 minus.
Very good. And on the bottom, we're going to subtract which 2 numbers?
5 and 0.
5 minus 0. So now this gives me a negative what on the top? 350 divided by 5. So that's going to be a negative what for slope? That's going to be a negative. Okay. That's okay, babe. So every year, inventory drops by 70. That's why it's a negative. Getting rid of 70 pieces of inventory every year. All right, of stuffed animals. So now, what's going to be my Y-intercept? What's my starting inventory? 350. So how do I write this as an equation?
Y equals negative 78x plus 350.
Very good. Okay, and we this all of these that we did this week, even though we're doing exponential functions, these are all linear functions because they have constant rates of change. Okay. Any questions about this? Okay. All right. Let's go ahead and I'm gonna make a homework help video for this. Okay. Then you ask yes for that. Yes, baby. Yeah, I think you can be the next person. So it's up there, right? Yeah. All right, so let's take out our interactive notebook and our this that looks like that. And you need your calculator. Yep.
Did you say you wanted us to do this right now?
I did.
What page would that be?
That's page 15. Okay. So yesterday, if you don't remember, we did paste this down at page 15. Okay. The title of that page is Expo Growth, Decay, Cut, Paste. I'm going to pause here. We're going to do page 16. This is graphing exponential functions. And then we're going to go to our booklet, okay? There's a couple things I need to show you in the calculator as well. So please make sure that you have gotten your calculator. This is going to be graphing exponential functions. Q3, we have page 16. We're graphing. We started a little bit of graphing yesterday, but we didn't get to finish. Graphing exponential functions. There are going to be two ways to graph an exponential function. There are going to be two ways to graph an exponential function. Okay. The first way that we're going to graph exponential functions is very, very simple. We just type it in the calculator. So we use the calculator. And the other is to create a function table. These are the two ways to graph exponential functions. Okay, and I'll pause real quickly, give you a chance to write, and then we'll go over both. All right, let's do it. Okay, first we're going to graph it in the calculator. So we're going to choose a very easy function for this. We're going to choose y is equal to, let's do 2 times 3 raised to the x power. This is an exponential function that we're going to graph in the calculator. Okay. We're going to clear our calculator. 2 plus 7, 1, 2. And the first place that we're going to go to our calculator is the y equals. Okay, we're going to press y equals. Probably should put press, just in case you go back and read your notes, you don't know. So we're going to press y equals. And we're going to type in the equation. So that's going to be 2 times 3. We use the caret key. Caret key's right here for exponent to the x power. This is where your x is. So we got 2 times 3, or you can put it in parentheses, same as multiplication. Caret keys right here to the x power. Any questions? Yes, baby.
Can you go back?
Where am I going back to?
Well, can you,
Y equals?
yeah, okay, so, and then you type it that.
Type in the equation. That's all I did. Yes. Just go. Yes, baby. It died. Use 22, baby. Can you sit that one on my desk so I can put batteries in it? Thank you. All right, so after this, all you got to do from here is press graph. Okay, so all you're doing from here is just press graph. Come on, hurry up. Sharpen pencil and go sit down, baby. There you go. All right. Listen, this is super important. If for whatever reason your graph doesn't show, it's because your window range is not big enough. Okay. So I'm going to put a little star here so you'll know. Okay. If the coordinate plane is not big enough, it's not big enough, y'all. This is what you have to do. You're going to go, you see where it says zoom? You're going to press zoom. You're going to press zoom. Okay. You're going to go down to where it says zoom or Z, zoom fit. Okay. You're going to select zoom fit. Press enter on zoom fit. Okay. And that way the calculator can put a coordinate, give you a coordinate plane that's going to be better for, so you are able to see it. It zooms in. Okay. Any questions about that? The zoom in and zoom out, if you want to zoom in, you can go here. If you want to zoom in a little bit more, you press zoom in. Okay. We can't zoom in much more than the way we had it. To zoom back out, you press zoom out and just keep pressing enter until you get to press enter for zoom out. I want to zoom out some more. And you just press enter for zoom out, okay? If you wanted to go back to where the coordinate plane was 10 up, 10 down, 10 to the left, 10 to the right, you go to zoom. Well, it's still working. You see how it's still moving? Still working. My calculator's still working. That's what happens when you try to press too many, rush, you try to press too many buttons at a time. It gets stuck. Sometimes I try to be patient and let it go, and other times I can't.
I cut mine off.
Yeah, sometimes I just can't be patient enough to wait. Isn't that awful? I just can't do it. All right, so if you want to go back, you press the zoom button and you go down to the standard. Standard is where it has 10 up, 10 down, 10 to the left, 10 to the right. That's the standard coordinate plane for a calculator. Any questions about that? All right, so let's do another kind of example. I'll start that today. And we're going to create a function table now. Okay? When you create a function table, you have your x. We're going to put our function rule in the middle. And we're going to put our y on the end. Okay? Let's do -1. Let's substitute -1 in for x. So we have y is equal to 2 times 3 to the -1. We're going to do this without the calculator because sometimes you will have problems like this without the calculator. So please push that to the side. Okay, so we're substituting -1 in the place of x. All right, so let's look at this. We got 2 times, how do we write 3 to the -1 power? 1 over
3.
now 3 to the first power. Or just what now?
3.
3. How do I write 2 as a fraction?
2 over 1.
2 over 1. So now what am I going to get as my answer here? What over what? 2 over 3. So this is going to be 2 over 3. So my ordered pair here is going to be -1 comma what? 2 over 3, 2/3. Yes.
Does it matter what number you put in?
It doesn't. I would use only small numbers though, because you have to graph these. So if you use a big number, you got to graph that. So that's why you see me sticking to small numbers. So -2, -1, 0, 1, 2, 3. Use those first. Don't use big numbers because then you got to graph those big numbers. Okay, let's do 0. We already should know by looking at the equation what our starting amount is going to be. What is the starting amount going to be? 2. Okay, we're going to substitute anyway. We got y is equal to 2 times 3 to the 0 power. What's 3 to the 0 power?
1.
So we got 2 times 1. What's 2 times 1?
2.
2. So our ordered pair here is going to be what? 0, 2. Our ordered pair here is going to be 0, 2. Let's do 1. Now we got y is equal to 2 times 3 to the 1 power. We got to do exponent first. What's 3 to the first power?
3.
So we got 2 times 3. What's 2 times 3?
6.
6. So what's our ordered pair?
1, 6.
1, 6. Let's do another one. Let's do 2. We got y is equal to, I need to do enough points so I can see a curve. I can't just do 2 points because that's going to be a straight line. So you got to do at least 4 points or so you can see the curve. If you can't see the curve, then you need to keep doing numbers until you can see the curve. All right, so let's do this one. We got 2 times 3 to the second power. Exponent comes first. What's 3 to the second power?
9.
What's 2 times 9?
18.
18. So now we got, okay, so this should be enough points for a curve. So now you would graph. right, let's see. So we got -1, and we got 2 over 3. What decimal is 2 over 3? Point what?
6, 7.
So that's gonna the halfway mark. The halfway mark is somewhere in here, so it's gonna be a little bit above the half. So maybe like right in here. Then we have 0 and 2. This is 0 and go up how many?
2.
2. Then we have 1 and 6, so we got go up and then go over and up how many?
6.
Then we got 2 and 18. So we got 2. I was able to go up to 12. 18 will be up here somewhere. And you see how it's kind of a curve. Any questions about this one? Those are the only two methods you can use for graphing an exponential function. Is there anyone that's lost?
No.
All right, so let's look at our booklet. Anyone still copying? All right. Yes. No, not yet. I'm going to paste the booklet down till we're finished with it. Just keep it in your folder because it's going to be hard to maneuver if we paste it in this book just now. All right, so let's check these. I'm going to clear my calculator. 2nd plus 7, 1, 2. And we're going to type these in the calculator and then graph the ordered pairs. We're going to do this one right here. Go to y equals. And we're going to type in 2 times 1.5 caret key to the x power. Now let's view our function table. What button do I press for my function? 2 buttons, sorry. Second graph. Okay, so now we got 0 and 2. We got 1 and 3. We have what? 3 and 4.5. And what's another point?
4.
Right. And what's one? What is that as a fraction? Anybody remember? You know how to type it in when you need to figure that out? A fraction, 1.125. You can type in 0.125 math. Enter if you forget, and that's 1/8. Okay. It's easier sometimes to just estimate the decimal. So most of the time I just keep it as a decimal. So this is going to be 4 and 10.125. All right, so when we graph these ordered pairs, graph the ones that you can. You got to estimate. So you got -3. Go over to -3. 1, 2, 3, and 16 over 27. The decimal for 16 over 27. That's what? You see it? It's about 60, right? So it's a little bit over half. Then -1 and 1.3, -1, and then go up. This is 1, and 0.3 is a little below the half. And then 0 and 2, this is 0, and go up 2. And then 1 and 3, and then 3 and 4.5, and then 4 and 10. And a little bit above 10. Yes. Go ahead, babe.
Do you think you can zoom in a little bit?
Mm-hmm.
What was your first?
It's in your calculator. Did you not type it in? I actually type it in. Did you type it?
No.
Then you need to type it, sir. Because you're not going to be able to see mine until you type it. That's why we typed it in. Type it in. And then go to second graph so you can see the points for yourself. That's why we did it, because this right here is small. What's the growth factor? Which one, babe? 2 and 4. Dang, I skipped 2, didn't I? Sure did. Thank you, baby. I did. I skipped 2. Did I skip 3 also? No, just 2. Okay. Sorry, y'all. Skipped 2 altogether. I skipped 2. 2 and then go up. 1, 2, 3, 4. Oh, be careful. I know. Who is always dropping the calculator? Come on. Normally. Yeah, it is. The person talking. All right, what's the, he drops it every day. What's the growth factor? 1.5. That's our B. That's what you multiply to get to the next number. Right here is B. That's our growth factor. How do we find our growth rate, the percent that it increases by?
Subtract 1 from the growth rate.
It's B is equal to 1 plus. Okay, so now what do you substitute?
You substitute the R for it would be 1.5.
The B. The B for 1.5.
The B for 1.5. This is one of the most missed questions because people just look at it and assume instead of just plugging it in. You gotta plug this in to see it or you're gonna miss this question, and it's really, really easy. What do I do to get R by itself? Subtract 1. When I subtract 1, what does that give me?
0.5.
I get 0.5. It's equal to R. So what's the growth rate?
0.5.
It's 0.5 or what percent?
50%.
Or 50%. Okay, this is a 50% what? Increase. What's the initial value?
2.
The initial value is 2. Please stop, Dalton. I mean, I haven't seen you do it like 3 times. Please stop. No, I don't care. Stop. Shh. All right, here we go. Donnie, you don't even know what's going on half the time. You wrote it, but that I didn't say you didn't write it. I said you don't even know what's going on half the time. All right, let's do this one. Go to our calculator. Y equals. Clear the equation that's there. And type in this equation. 2 parentheses. 1 divided by 3. That's 1/3. Caret key. X power. Now we're going to view the function table. That second table. Okay. And let's type this in. Now look, this one, if you need to know What would be the fraction here? If it's repeating, this would be what?
So 2/3.
This, okay, good. Remember, if there's only one number repeating, I don't know if you all learned this from previous grades, but I'll tell you. If you have one number that's repeating, like the 6 is repeating, the fraction is 6/9 and you reduce it. What can I reduce this by?
3.
I can reduce it by 3, and so that gives me what? 2/3. If I had 5 repeating, this will be 5/9. Okay. If I had 2 repeating, this would be 2/9. If I had 3 repeating, this would be 3/, and reduce it. Don't forget to reduce these. How do you reduce this? Divide by 3, and that gives you what?
1/3.
1/3, and so on and so forth. So if you have one number repeat, then the denominator is going to be 9. Okay, so that's a good way to know what some of these are. Okay, or I got to, yes, I will. Okay,
No, do it now.
okay,
I just
yes,
need it
ma'am.
for the D1.
Okay, yes, ma'am. All right, let's keep going. Okay, so for this one, this is 0 and 2. Then the next one is going to be 1 and 2/3, or you can leave it as the fraction 0.6 repeating. Sometimes it's easier to see where to graph it with the decimal than it is to see with the fraction. And then the next one is going to be 2 and what? 0.2. And just keeps getting smaller. So we need some numbers that are larger. So go up this way. We got -1 and 6. Because we need to see a curve, okay? Okay. Go up some more. We got -2 and what? 18. Let's see if this gives us enough points. Okay. So let's graph. We got 0 and 2. We got 1 and 0.6. So this is 1. And 0.6 is a little bit above the halfway mark. Then we got 2 and 0.2. That's really small. 2.2 is really close to 0. Okay, and then we got -1 and 6. Go over to -1 and up. 1, 2, 3, 4, 5, 6. And then we got -2 and 18. And that's, so this is what it kind of looks like. All right. What's our decay factor? 1/3. How do we find our decay rate? What do we do? What do we use to find decay rate?
B equals 1 minus R.
Okay, and what do we substitute for B?
1/3.
1/3.
So we got 1/3 is equal to 1 minus R. How do we get R by itself?
Subtract 1.
When we subtract 1 from both sides, that gives us a negative what?
1 and 1/3. -1 and 1/3.
Negative 2/3 is equal to what? Negative R. Okay, when you divide both sides by a negative, that's going to make it positive. What's the decimal for 2/3? 0.6. Repeating, right? So what percent is this? 66%. What's the initial value?
2.
Please put your calculators back.